Alright, so here we're going to continue with working with the exponent laws, but we're going to step it up a little bit and deal a little bit more with expressions that involve some fractions and a combination of fractions and negative exponents. So the first one, we'll start out with a to the 1/2, b to the negative 1/3 raised to the 1/2 times a to the negative 2 b to the 1/2 raised to the negative 1/2. So what I notice is I've got two expressions here. This exponent right here is negative 1/2, but you can't quite see. I'll put it down there. Okay? You've got two expressions here with brackets around them and an exponent up there. So the exponent is going to have to go on each piece that's inside each set of brackets. So in this case, for this bracket here, the first term is a to the 1/2. It's got to receive this exponent. The next term is b to the negative 1/3. It's got to receive that exponent. Okay? Next set of brackets here, so a to the negative 2 has to get this exponent, negative 1/2, and then b to the 1/2 has to get that negative 1/2 exponent as well. Alright, and now we're just using our power of the power rules, so a to the 1/2 raised to the 1/2, I multiply the exponents. So 1/2 times 1/2 is 1 times 1 is 1, 2 times 2 is 4, so a to the 1/4. b, negative 1 times 1 is negative 1, 3 times 2 is 6, so negative 1/6. Next term, so a to the negative 2 times negative 1 is a positive 2, and then 1 times 2 is a positive 2, and then b to the 1 times negative 1 is negative 1, and then 2 times 2 is 4. I'm going to put my a's together, so this is going to give me a to the 1/4 times a 2/2 reduces to just 1, so I'll leave that as a to the 1 for now, times b to the negative 1/6 times b to the negative 1/4. And now all I need to do is pair these together and add these exponents. So I'm going to do 1/4 plus 1/1. Remember, when you're adding fractions, you always need to get common denominators. So in this case, my common denominator between 1 and 4 would be 4. This denominator is already a 4, so I don't need to change it. And this denominator is a 1, so to change the 1 to a 4, I multiply by 4. Well, that means I need to multiply the numerator by 4 as well to get 4/4. And then adding these together gives me 5/4. So this tells me I've got a to the 5/4. And over here I'm going to add these two together, negative 1/6 plus negative 1/4. And that will give me the exponent on b. So negative 1/6 plus negative 1/4. Common denominator between 6 and 4. Well, you could use 24, but I think 12 is the least common denominator because both of these numbers go into 12. So when I change that denominator to 12, 6 times 2 gives me 12, so that means I need to multiply the 1 by 2 to give me 2. And then 4 times 3 gives me 12, so I'll multiply the 1 by 3. Then negative 2 plus negative 3 gives me negative 5/12. So my exponent on b is negative 5/12. And then to write my final answer, I need to use all positive exponents. This is a negative exponent, so I can put my denominator down here and take this term and push it down there to get my final answer of a to the 5/4 over b to the 5/12. Okay? That's the first one done. So in questions like this, you'll deal with adding, subtracting, multiplying fractions a lot. So if you are a little bit uncomfortable with that, you may want to review how to handle fractions in that kind of situation. And of course, always don't hesitate to reach out if you need help with it. Let's look at another example. So we've got 8x to the negative 2, y to the 1/2, oops, no bracket yet, over x to the negative 3 over 2, y to the negative 1/3, bracket around all of that, exponent 1/3. So again, I'm going to deal with like terms that are inside the brackets. There's an 8 up here, but there's no like number term down here, so I'm just going to leave the 8 where it is for now. Then for the x terms, of course, just like last time, we subtract the exponent. So I do negative 2 minus negative 3 over 2. So negative 2 minus negative 3 over 2, negative 2 over 1. Get your common denominator, which in this case will be 2. That one stays the same. And this one becomes a negative 4. So then, at negative 4, subtract negative 3. Remember, subtracting a negative is the same as addition. So negative 4 plus 3 is negative 1 over 2. So my exponent on x is negative 1 over 2. And then for my y terms, I am going to essentially do the same thing with those exponents. So I'm going to do 1/2 minus negative 1/3, 1/2 minus negative 1/3. Common denominator in this case would be 6. So 2 times 3 gives me 6, so 1 times 3 is 3. 3 times 2 is 6, so that gives me a 2 right there. Subtracting a negative is the same as addition, so this gives me 5 over 6. So my y exponent is 5 over 6. And remember, all of this has exponent 1/3, so that means my exponent 1/3 goes right there. Alright, let's get rid of this now since we're done with that. And now, what I need to do is apply this exponent on each term that's inside the brackets. That includes the 8. Don't forget to put the exponent on this coefficient term if you have a coefficient like that. It's a common mistake to forget to do that. So this is going to be 8 to the 1/3 times x to the negative 1/2 to the 1/3 times y to the 5 over 6 to the 1/3. Okay, so that first term there, 8 to the 1/3, there's no variable on it or anything. So I really need to try to evaluate that as it is. And remember, an exponent of 1/3 is really just a cubed root. So having 8 to the 1/3 is really just the cubed root of 8. And the cubed root of 8 is just 2. So this tells me that this just simplifies to be 2. Then I'm going to multiply these exponents together. Negative 1 times 1 is negative 1. 2 times 3 is 6, so over 6. My y term now. 5 times 1 is 5. 6 times 3 is 18, so 5 over 18. Write my final answer now using all positive exponents. I'll put my denominator down. Bring this down here. Becomes positive. In my numerator, I'm left with the 2 and the y term. So I'm left with 2y to the 5 over 18 over, this comes down into the denominator with positive exponents. So that's my final answer. This one involves a little bit of everything. So if you can do a question like this and feel confident about it, then I would say that you're pretty strong with the exponent laws. Alright, so when I look at a problem like this, I see a negative exponent. I immediately think I'm just going to take whatever's inside before I even deal with it. and I'm going to flip it. That's one way to attack this. So you could flip everything inside and then work with it. Or you could work with what's inside first and flip after. It doesn't really matter. But let's stick with the process we've been doing first. For now, let's work with what's inside and then deal with this exponent after. So inside, the 9 and the 4, I can't reduce 9 and 4, so I leave them as they are. Here, x to the 1/2 and x to the negative 2/3, what I will do is subtract these, so it's going to be 1/2 minus negative 2/3. Common denominator here is 6. 2 times 3 is 6. 3 times 2 is 6, so negative 2 times 2 is negative 4. Subtracting a negative is the same as addition. So this gives me 7/6. So I have x to the 7/6. And look at my y term. Next, I've got a numerator of y to the negative 1/4 and a denominator of y to the negative 4/3. So I'm going to have to do negative 1/4 subtract negative 4/3. Denominator here between these two would be 12. 4 times 3 gives me 12, so negative 1 times 3 is negative 3. 3 times 4 gives me 12, so negative 4 times 4 is negative 16. Subtracting a negative is the same as addition. So negative 3 plus 16 is a positive 13/12. So y to the 13/12. My exponent is negative 3/2 right here. Okay, from here, again, you've got options as to how to deal with this, but let's just stick with what we've done before, which is to apply this exponent to everything that's inside the bracket. So the 9 is going to get that exponent, so is the x, so is the y, and so is the 4. So this is going to give me 9 to the negative 3/2 times x to the 7/6 to the negative 3/2 times y to the 13/12 to the negative 3/2 over 4 to the negative 3/2. That's a 2 right there. Okay, running out of space, so I'll have to get rid of this. So at this point, you've got the power rule again. So remember that when you've got a power raised to an exponent, you multiply your exponents together. So I'll come back to these terms in a bit. So for this x term here, I'm going to do 7 times negative 3, which is negative 21. 6 times 2 is 12/12. And then for this term here, 13 times negative 3 is negative 39. And 12 times 2 is 24. Now these terms right here, 9 to the negative 3/2 and 4 to the negative 3/2. I'm actually going to leave them the way they are for now. Yeah, that's probably the easiest way to do it for now. And 4 to the negative 3/2. Now, let's deal with our negative exponents, because we've got a lot of them. So remember, when you have negative exponents, you just change the position. So this term is in the numerator with a negative exponent. So what's going to happen to it is it's going to go down into the denominator. So this is going to have a 9 to the now a positive 3/2. This term's in the numerator with a negative exponent, so it's going to go down into the denominator. And now the exponent's going to be a positive 21/12. This exponent is negative, so it's going to go down into the denominator as well and become positive. This one has a negative exponent. It's in the denominator, so it's actually going to end up going up to the numerator and have a positive exponent. Now these two terms here, there isn't much you can do. You can't reduce, can you? Oh, these are both divisible by 3 right here. 21 and 12 are both divisible by 3, right? So I can divide 21 by 12 to give me 7, and 21 by 3 to give me 7, and 12 by 3 to give me 4. So that should actually be 7 over 4. And then 39 and 24, well 39 is a prime number, so that one's not going to reduce. These terms here are just fractional exponents, which are just radicals, right? So 4 to the 3 over 2 is just, denominator is 2, that means it's a square root of 4, exponent 3. Square root of 4 is 2, so this becomes 2 cubed, which is just 8. So my denominator, this term here, just becomes 8. This term here, 9 to the 3 over 2, well 9 to the 3 over 2 is, denominator's 2 again, so this is a square root of 9 cubed. Square root of 9 is 3 cubed, which gives me 27. So over 27, and then I can write these terms down. 7 over 4, and then y to the 39 over 24. And then you would double check to make sure the 8 and the 27 couldn't reduce, and they can't. So that's the final answer.